In today's lesson, we are going to be looking at present value, annuities, and TVM solvers. There's going to be a few concepts in one, but they all kind of relate to the same idea of calculating interest or calculating certain values based off of different interest scenarios. So the first thing we're going to look at is present value. So in the previous lesson, we looked at how to calculate compound interest and simple interest, and we used that to determine how much we would owe in total at the end of a term, whether we were borrowing money or saving money. Now, in a different sense, we may be looking not just for what we have in the end, but maybe we know what we want to have in the end. We need to know what we start with, right? This might be more practical where we're thinking of if we're saving for university or saving for college or saving for a car or a big purchase. We know how much we want to have in the future. We just don't know how much to put down now or how much to start with, right? So we might be looking for the present value instead of the future value. And there is a specific formula that we can use for that, and it's very similar to our compound interest formula. We just have a few things that are switched around. So if we look at our formula here, P equals A times 1 plus I to the power of negative n. So it's very similar to the other one that we dealt with, except the A and the P are switched, and we have a negative on our exponent. And that's going to be important, right? We do want to make sure we remember that negative there. The variables still represent the same thing. So A still represents the future value. P still represents the present value. I and N are the two ones that we do have to do small calculations with before we incorporate them into our actual formula. But all the variables are the same as the compound interest formula. So let's look at example with Michelle's grandparents. They want to retire with $150,000 in the bank in 9 years from now. How much should they invest now at an interest rate of 5.75% per annum or per year, compounded quarterly? Again, the compounded quarterly is telling us that we are dealing with compound interest. So let's look for our A, P, I, and N. Because we're looking for the questions asking about how much should they invest now, that should be a key indicator that we're looking for the present value, right? How much do we need now? How much do we need today? How much should we start with? Those are different phrases that we might come across that are asking for the present value. So we do have to make sure we are reading the question carefully. So for our A value, A is our future amount. That is our 1,000 or 150,000. Our P, our principal, our present value, we don't know. Our I, we're going to do a small calculation. We're going to take our percent or our rate as a decimal, 0.0575, divide it by the compound number or the number of periods per year. Because it's compounded quarterly, quarterly means 4 times a year. So we're going to take that 0.0575 or that 5.75% and divide it by 4. And we get 0.014375. So we're taking that 5.75%, dividing it up or dividing it into 4 for each quarter, and we get basically about 1.4375% each quarter. Our N, right? N is the total number of compounding periods, so it is 9 years, and because it's quarterly, it's 4 times a year for 9 years, so 9 times 4 is 36, so that is our N value. Now we can plug everything into our formula. P equals A times 1 plus I to the power of negative n. I have 1,500 or 1,000 or 150,000 times 1 plus 0.01375 to the power of negative 36. And now this is just a calculation that we can do in our calculator. Again, it might take multiple steps depending on how comfortable you are with your calculator. One thing you can be looking for is you should have a number smaller than what your A value is. If we calculate it, we should get $89,731.29. So again, rounding to 2 decimal places. So that means if we wanted to retire with just this account at this specific interest rate, to have $150,000 at the end of 9 years, we would need to invest into that account $89,731.29. Now, with a lot of these calculations, you may not be using a calculator. Right? There's a lot of different calculations that we could be doing, and because they're all kind of variations on the same type of formula, there are such things called TVM solvers. So time value money solvers, I believe, is what the acronym stands for. And these basically allow us to quickly do these financial calculations by entering in specific values. And sometimes it's helpful to have these calculators to quickly do these calculations, because we might want to be testing out, or we might want to see what some of the options are, what things are changing, or how, if I find something at a slightly better rate, how do things change? Or if I want to play around with some of the values. We don't want to have to do these long calculations every time when we're trying to plan financially or things like that. So these TVM solvers do make it really easy to kind of just plug values in quickly and solve for what we're looking for. Now, there are a lot of variables in these TVM solvers, so we need to know what these variables represent, so we know we're plugging our numbers into the correct spot. N represents the term of the investment or loan. So that is the number of periods or number of deposits. That's the total number, right? So that is just like your N value from the equation. I, or I%, represents the interest rate. And in this case, you are going to be leaving it as a percent. You don't have to do any conversions here to decimals. PV represents the present value or principal. PMT represents the amount of regular payments. Now, this a regular payment we're going to look at in a second, but that might be something where you are putting money into an account every month, right? When you think of saving something, you're not necessarily saving or putting money in once and leaving it. You might be putting in, say, $50 every month or something like that. So that's what PMT represents. In all of the examples that we've looked at so far, the PMT has always been zero. We haven't had regular payments. We've had one initial amount go in, and that was it, right? We weren't adding money to the account or adding money to the savings or things like that. Now, when you are depositing money into an account, when you're putting money in, it is going to be a negative value. FV represents the future value or final amount. If we're dealing with a loan, right, we've borrowed money, our future value should be zero, because that means we've paid it off, or we've paid off the amount. P/Y, or depending on the calculator, PPY, this represents the number of payments per year, and CY or CPY represents the number of compounding periods per year. Now, usually these two tend to be the same value. Usually you're putting money in at the same compounding period as your, or in the same frequency as your compounding period. Some calculators, usually only in physical calculators, there's a PMT end or there's a begin. This basically just tells us when the payments are being entered, or when the payments are being put into the account. And for our purposes, we're always going to leave it at the end. So that means the payments are always at the end of the interval, right? So at the end of the month, we put our payment in, not the beginning. So there's no interest being calculated on it until the end of that month. So let's look at an example. So determine the future value of a $500 investment if the annual interest rate is 4.9%, compounded monthly for 3 years. Now we're going to use a TVM solver similar to what you see here. So I just Googled TVM solver. This is one of the ones that came up. In class, we will use the graphing calculators to use their TVM solver. But this is an example of what it looks like. We see our variables here, and we need to make sure we understand the correct values that go in. So if we go back to our scenario, N is the total number of periods or the total number of payments. In this case, because it's compounded monthly for 3 years, our N value is 3 years times 12 months a year equals 36. Our I% is our interest rate as a percent. We don't need to change it, so we can just write 4.8. Our present value is what we're putting in, what we're starting with. In this case, it's 500. Our PMT, because we're not making any regular payments, we're going to leave it as 0. FV is what we're looking for, so we're going to leave it blank. PY and CY, payments per year. Usually, even if we put compounding periods, we can start with that. So there's 12 compounding periods per year because it's compounded monthly. Usually the calculator will automatically change the payments per year to that value as well. Now, because the payment is 0, that means we're not adding anything every month, so it doesn't matter really what our PY is. But generally speaking, it should be the same as the compounding periods. So if we go to our TVM solver and we enter the same thing, I'm gonna bring my keyboard over. So 36, our I% is 4.8, our present value is 500, PMT is 0, compounding periods is 12, and make that 12 as well. And what we do is we just click on solve for future value. So in this case, our future value is negative 577.28. In this case, don't worry so much about the negatives. When we're depositing or when we're dealing with the payments, we do want to put negative values in. If we just go back up for the payment, it will be negative if we're depositing money into an account. If we're putting money back in, that will make it a negative value because we don't have the money anymore, our account does. Similar in this case, it's kind of looking at a similar thing. We don't have the negative money, but our account does. If we wanted to double check the work as well, just to make sure we did everything right, again, we can go and use our compound interest formula. A equals P times 1 plus I to the power of N. So 500 times 1 plus I, which would be 4.8 divided, or sorry, not 4.8, oops, 0.048 divided by 12, or 0.004 to the power of 36. And if we do this on our calculator, provided we used that TVM solver correctly, which we did because we get 577.28 for our answer. Oops. Sorry, you can't see that. So we do get the same answer whether we're using the compound interest formula or whether we're using our TVM solver. So just seeing that visually you do get the same answer. Now this is helpful, or more helpful with annuities, because with annuities, or what an annuity is, it's equal payments over equal intervals of time. So basically we're putting in regular payments. Right now this could be payments on a loan, so like a mortgage where we're putting money in or we're depositing money, or it could be like payouts, like insurance, where we're being paid out a certain amount every month or whatever the case may be. So with the annuities, it is going to be very helpful to use the TVM solvers because it allows us to add in those regular payments without having to do a lot of calculations. All the calculations are going to be done behind the scenes in the program. We don't have to do specific calculations where we're calculating the interest, adding in the payment, calculating the interest again, adding the payment plus the interest, and so on and so on and so on. So in this example, when their son was a month old and at the end of every month thereafter, Chris and Ashley invested a total of $75 into an RESP, a registered education savings plan, that paid 6.45 annual interest compounded monthly. We want to figure out the amount in the fund on the child's 7th, 10th, and 17th birthday. So on the 7th birthday, because it's compounded monthly, it's 7 times 12, or 84. The percent is going to be 6.45. The present value, because we started at 0. We had nothing in there initially. The payment was $75. The future value, we don't know. The payments per year is 12 because they're putting it in every month, and the compounding periods is monthly. So this is a little different because now we do have a payment because we have the regular payment of $75. So now if we go back to our TVM solver, we're going to clear everything. N is 84. I percent is 0.645. Present value is 0. Payment is 75, so we're putting in regular payments of $75. Compounding period per year is 12. Payments per year is 12. We check our future value. We get $7,936.03. So in 7 years, by putting in $75 every month, we have $7,936 $7,936.30. If we do the same thing for, let's go back to our screen. If we could do the same thing for the 10th birthday, 10 times 12 equals 120. Everything else is going to stay the same. We don't have to redo the calculations. We don't have to change anything. We can just, again, assume it's like a separate calculation. We just have a longer or a larger n value. So if we go back, we can just change this to 120, click solve, and we can see, okay, our future value is going to be $12,595, and if we click on and 78 cents. In the last one, right, looking at 17th birthday, so 17 times 12, because it's compounded monthly for 17 years. 17 times 12 is 204. Everything else is going to stay the same. Was it 6.45? Present value is 0 because, again, we're imagining we're starting from 0 from the day he was born. 75 is our payment. That's how much we're putting in weekly or monthly, sorry. Payments per year is 12 because it's monthly payments. Compounding periods per year is 12 because it's compounded monthly. And if we go back to our TVM solver and we change that to 204, go down and say we want to solve for the future value. So $27,696.17. So again, just how we can use the TVM solvers to now calculate financial questions or interest questions involving annuities with regular payments. So by the time their son turned 17, how much of their own money had they invested? Well, if we go and look at 17, there's 204 payments or compounding periods. But if it's 204 payments times $75 a payment, is $15,300. So they put in $15,300 of their own money into this investment. How much RESP did it earn? Or how much interest, did it earn? Well, if we take the new amount, or how much they have in total, this $27,696.17 minus the $15,300 of their own money that they put in, the amount of interest that they earned is $12,396.17. Again, you might think, okay, over 17 years, that's not a lot, but again, you haven't done anything, or you haven't had to do anything to really earn this, right? So again, it's kind of that trade-off of how much work are you really putting in versus what you get back, right? You're not putting any work in really except for depositing money, and you're making $12,000 over 17 years. If they wanted there to be $30,000 saved by the time their son was 17, how much would their monthly deposit have to be? So again, this is where these TVM solvers are really helpful, because it allows us to do these kind of questions very easily. Right? We're gonna have to still determine our variables and plug them in, but it is a lot easier than doing the calculations by hand. So the new thing here is they want there to be $30,000 saved by the time their son is 17. That means that future value has to be $30,000. Nothing else is changing. The payments per year is still 12. The compounding periods per year is still 12. The present value is 0. It's still going to be a 6.45% interest, I believe. Yep, 6.45% interest. And because their son is going to be 17, it's 204 total payments, or that's the length of the term, right? 204 months, 204 total payments, however you want to describe it. Now, again, because the question is asking how much would their monthly deposit have to be, we're leaving this blank. We're leaving the payment part blank. So we don't know what the payment is. And again, we might, if we were doing this by hand, using hand calculations, it would probably be a lot harder, because we'd have to rearrange and kind of work backwards and do multiple calculations to get the payment. But with the TVM solver, it's really easy, because we're just going to change. We're going to make it negative 3,000, and we'll look at the difference if we don't include that negative. The payments per year, we're getting rid of that. We don't know what it's going to be. 2,000 or 204 for the number or the length of the term. 645 or 6.45 for the interest rate. $30,000 is what we want to have in the future. We starting with nothing. Payments per year is 12. Compounding periods per year is 12. Let's click solve for payment. They have to invest $81.24. So that is how much we would need to invest. Now, if I change this to a positive and I click solve, it would just make this a negative. So as long as we understand it's not going to be a negative value, the way the TVM solver looks at it, it's more of either the money's being deposited into an account or taking off something, or again, like you're losing that money because you don't have it anymore. You're giving it up by putting it into the account. Don't worry too much about that, as long as you understand, okay, the 81.24 is going to be how much we have to put into this account. Right, so again, with the TVM solvers, it does make it a lot easier to do the calculations. It doesn't hurt to know how to do them by hand if we are doing some more simple compound interest questions, similar to what we started with and what we looked at last week. But any of the compound interest questions, like we saw in example 2, or the annuities questions, you are going to want to make sure you understand how to use the TVM solver, because that will make it easier to do some of these calculations. But again, it's all really a play on exponential functions in general. Now we're just looking at some different scenarios, different types of finance, and some easy ways that we can use technology to our benefit to help answer some of these questions.